Um, see if I can do that. All right. Any other questions?
Could you explain the second right-hand rule? I joined a little late,
Yep.
so I missed the little first part.
So the general explanation is, man, I keep losing this wire. Here's the general explanation. If you have a current going down a wire, we'll say the current's going this way. Currents produce magnetic fields around them. And the way you tell how it's going around the wire is you take your right hand and then you grab the wire with your thumb pointing in the direction of the current. So if the current was going this way, then I would grab the wire this way. And then my fingers indicate the direction of the magnetic field as it's going around the wire. So behind the wire, the magnetic field points that way. On this side of the wire, I don't know what you call that, it's pointing out of the board, right? Above the wire, on your side of the wire, it's pointing this way. So it's doing a circle all the way around the wire, sort of like this, right? It's doing a circle this way. And so it's pointing out here, it's pointing that way here. On this side, it's pointing down, and on that side, it's pointing that way. And so I can tell just by grabbing the wire which way it's pointed in any position around the wire, just by sort of drawing a little circle in my mind around the wire. And in this case, it would be you know, going around like that. Did that answer your question?
Yeah.
I have a question while you still have that in your hand. I'm sorry.
Shoot.
Okay, so I was trying, because I didn't understand that fully, and I tried to watch a YouTube video on it.
Okay.
And I guess I was confused. Whenever you had that in your hand, the fingers are pointing down. They're not curving back into your hand, correct?
The fingers are pointing down. I don't know what that means.
I don't either. I guess you don't curve your hands or your fingers below. We're acting like that's a wire. So you don't curve your fingers underneath the wire.
I'm trying to. If I could wrap them around it 6 times, I would.
So that is what you do.
Yeah, I'm trying.
Okay.
I'm trying to make my fingers a circle going all the way around the wire. And so.
Okay, perfect.
Okay, and so let me just say it one more time, and we'll see if we agree. So imagine my fingers are making little circles around the wire, and the the directions my fingers are going is the direction that the magnetic field goes. And so over here, my fingers are pointing this way, if you will. Over here, my fingers are pointing this way. Over here, on this side, my fingers are pointing that way. And underneath, even though that's not really fingers, my fingers are pointing that way. And so they're just a little circle as indicated by the direction my fingers are curled around it. So if you were to look at it edge on, here's what I would say. So now I'm going to take the wire and I'm going to let you look at it edge on like this. And I would grab it if the current's coming this way up the wire, right? So the current's going this way, but now I'm going to tip it towards you and the current's going this way towards you. And if you saw me grab it like this, if it was just absolutely end on, what you would see is this, right? And so over here, the magnetic field's pointing this way. Over here, it's pointing that way. Over here, it's pointing this way. And over here, it's pointing that way. So B, 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 B. I think it would be a lot easier if we were in a classroom, but.
Yeah, I think this is going to sound kind of crazy, but on my explanation on my exam, I've already turned it in. So I think basically what I said was kind of like structure and bonding. So that is kind of how you're doing it, right? Like you're picturing this coming straight at you.
Yes.
So imagine like a string going through it.
Straight at me.
Okay, that's what I was confused at on the exam because we had just taken obviously structure and bonding, so that had made a lot more sense once I looked at it and had saw that I gotten the answer wrong. So I was like, okay, so that's probably what's happening is it's coming straight up off the paper. So you have to imagine a string going through it and a circle around it.
Yeah, but not in this problem, right?
No, 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 no,
Yeah,
no, no,
okay,
no. The
okay,
one from the exam, like kind of like you drew to the left. Sorry,
yeah.
I didn't make it for this part on the right. I've been doing material stuff and I lost track of time. So sorry.
Oh, no, that's all right. I don't know anything about structure and bonding, so
That's okay.
I'm
That's
worried,
okay.
I'm worried about agreeing with you. I'm not sure. I'm not sure what that means.
No, that's fine. That's fine.
All right.
I guess, like I said, since I missed the front part, I just want to make sure again for the final on Wednesday, are we having any type of review or is this kind of like that review as well?
I was gonna just schedule. Well, you tell me. I'll do anything you guys want me to do. You want me to set something up for like Monday night and Tuesday night?
I personally don't have a final on Tuesday. I have one every other day of the week except for Tuesday. So that works for me. I just
So
don't
Monday
want
night would
anybody
help
else
you,
to.
right?
Yeah, Monday night or Tuesday night, either one. I have one final on Monday, but it'll be fine.
Let me
It's
just see
easy and it's in the morning.
how many people are here. So maybe 8 or 9. What if I did, somebody give me a time for Monday or tomorrow? Is 5:30 reasonable? Would you rather do it later? Is there any,
I personally do not care about 5:30 is fine with me, but I'm
all
one
right,
person.
so let's just say that. Is there anybody out there who would want to come who just can't make 5:30? All right. So what about Tuesday? Also 5:30? The nice thing about 5:30 is that it's not 8 o'clock, and so you're not tired already. Maybe you guys aren't tired. I'm tired already by 8 o'clock. I'm willing to do whatever you guys want to do.
5:30 works both days for me.
All right. So for now, we'll say it's 5:30. I'll put those up as an announcement and set up Zooms for those. And if somebody says that doesn't work, I'll either move one or add one or something like that. All right. I said at the start, I think when it started, it was just Jordan and me. But if you have questions about the redo on your test, I don't want to just go through and work all the problems on it because I kind of want you guys to do that. But if you're stuck on something, and this is why this problem came up, I'd be glad to try to get you unstuck. So if you have any questions about that, I would be glad to answer them. What time did I make that due?
12 o'clock.
Is it at noon?
Yeah.
Yeah,
Okay.
tomorrow.
All right.
I know this is completely random too, but for some reason when I scanned mine in, you couldn't see the answers very well. So I put an answer sheet on the back of mine as well, just so you know.
Thank you.
Dr. Trail,
Yeah.
is it too far-fetched to ask for a study guide?
A study guide. Probably.
Okay.
Yeah. I don't think I could distill stuff out of that very quickly. I mean, yeah. I don't have any really composite list of, I do stuff like that for astronomy, kind of.
Is this going to be like a 20 question thing, or is it going to be
40.
longer since it's composites? Okay, I didn't.
Yeah, it's the length of 2 tests. And I think you're
Okay.
going to have a 2-hour window, a 4-hour window to take it. You'll have 2 hours to take it. I mean, I don't generally have anybody last for 2 hours on my finals. Maybe 1 or 2 people out of the class. Whereas a lot of people are will take the full hour on a test. Usually on the final, that doesn't happen.
Is it at 8:30?
I think it's, I'll try to announce that tomorrow. I think it's going to run from like 8:30 to 12:30 or 8 to 12 or something like that. I think the university is requiring me to make a 4-hour window for it.
Okay.
I think that's right.
I was just checking because I have a final at 11. So
You have a final 11 on that day?
yes, I was just checking. When you said 4 hours, I was like, what?
Oh, yeah.
You're just giving extra time. I understand.
I think the university is trying to accommodate the fact that people have gone home and gotten jobs. And so they're trying to make us, which is good. They're trying to give a larger exam window to accommodate people who have other obligations. I'll try to be clear on that by tomorrow so that everybody can know. So did you guys, was the redo on the exam okay? Could people kind of figure those problems out? I guess if you're not asking me anything, either that or you haven't looked at it yet.
Yeah, I mean, if we made the final open notes, that'd be
Yeah.
swell. It was a lot easier because I got to use, YouTube and watch lots of videos as I did it.
Good.
So
Yeah.
I mean, it took like 3.5 hours, but
Here's the thing about open notes that I don't like. I thought about that for a while, and that's why I kind of settled on an equation sheet or an extra sheet of paper. How do I say this? I try to just put myself in the position of the person who's taking the test, and I was kind of a last minute sort of person. And so when you have open notes, it gives you, I think, a false sense of security. And that's why I don't like those tests. Whereas if I have you write down an equation sheet, you're going to spend some time thinking about the physics before you actually take the test. And I think hopefully that's enough paper for you guys to put something meaningful down on. And so anyway, that's kind of what I was thinking about there. That an open notes test requires harder problems, and it makes people spend a lot of time just sort of paging through stuff looking for things. And so I was just looking for something that required a little more advanced organization. So I don't know if it helps them out, but we'll see. You guys may be more organized than I was. Well, I guess I'm glad there aren't any physics questions for me. That means you guys were able to sort of wrestle your way through that redo.
Can I ask one more?
Yeah.
Okay. I know I'm pretty sure it has to do with the first right-hand rule, but on 17,
Yeah.
the current is flowing clockwise around the loop.
Yeah.
What's in the magnetic field at center point A, and I put it into the page and I got it right, but I just wanted to make sure my thought process on it was right, I guess.
So someone, I won't mention any names, but somebody asked me about 15 and 17 earlier, and I hadn't even realized the similarity of those two questions. It was a good question. And so I'll just talk about that for a second. A result of it, so you said 17.
Yes.
Right? So 17 is the loop rule. Do I have a, let me just see if I have a, hang on a second. I think I have a loop. Oh, yeah. So we'll pretend this is my loop, right? So I can get back to it. So let me just, in case people don't have the question out, right? 17 says this. It says, I have a loop of wire that's going this way. What's the direction of the magnetic field there? Right. And so who can tell me, first of all, what right-hand rule I would use for that?
So is that the second where you wrap it around? No, because we already know the current.
You were on it.
Oh, okay. You wrap it around and then.
If they're asking you for B, that's the second right-hand rule, generally. You can be sneaky and make them ask for B on the first right-hand rule, and maybe I'll give you an example of that. But generally speaking, if you have a wire and they're asking you for a magnetic field due to the wire, this is the one you want. The second right-hand rule is the one you want. So now, having said that, what did you do?
You wrapped it around and it was.
So what do I do with my hand?
You wrap it around the wire in the direction of the current.
Uh, what points in the direction of the current? Anybody? For the second right-hand rule, what points in the direction of the current?
Your thumb.
Yeah, my thumb, right? This would be a good one to write down on an extra sheet of paper, right? So I point my thumb and then I wrap my fingers around. Well, to wrap around, I have to jam them into the board. And so what's the direction of the magnetic field in the middle?
Into the page.
Yeah. And notice it doesn't matter where I grab it, right? As long as my thumb is pointing in the direction of the current, my fingers are going to go into the page. Notice if it was the other way, if the current was the other way, then I'd be grabbing it this way and be coming out of the page. I got a little loop of wire here, right? So if it was going the other way, it would be coming out of the page in the middle. If it's going this way, it's going into the page in the middle, right? And it doesn't matter where I grab it. As long as the wire loop's going around this way, my thumb is forced to.
Thank you.
Yeah, you bet. So let me just talk about 15 for a second, because 15 is saying something a little different. It's saying as a result of a uniform magnetic field, a proton is moving. So I've got a charge moving around in a circle like this, and it's doing this because of a magnetic field, right? That's what this problem is saying. And so it says, what's the direction of the magnetic field that's producing this force that's causing this thing to move in a circle, right? And so if it's moving in a circle and it's a positive charge, it means the force is this way, right? And so the on the first right-hand rule, the force, this is the direction of the force, right? The force has to be going towards the center if the thing's going in a circle, right? I'll pick a direction like here. So here, the velocity is this way. The force is that way. My arm goes in the direction of the velocity, and my fingers curl in the direction of the magnetic field. And so the magnetic field has to be out of the page to make a charge go in a positive charge go in a circle like that. And that's a first right-hand rule. And it's a little tricky because they're using it to ask you the direction of the magnetic field. But this is the force one. And you have to realize that for this guy to be moving in a circle, he's not forced to by being in a wire. He's just moving in a circle all on his own. And that's because the magnetic field is causing him to do that. And that's the first right-hand rule. I know you didn't ask that question.
It's okay. Thank you.
Yeah. So what else?
And for the final, I guess I forgot to ask this one. Chapters 23 and 24, you said 24 wouldn't be on there, correct?
Definitely not.
And then some of 23?
23 is, yeah, I was going to put something up about that.
I just didn't know if you had said yet. It's okay.
Here's what I'm going to do. I'm just going to leave 23 off the final. 23 is the one on the properties of light. Is that right? I was going to put a few little things on there. I'll tell you what, give me an hour or two tonight and I think I can give you, so I can give you a few definitions, like what is reflection and refraction. I can give you some that are pretty easy that you can know. And then you can just know those or write them down and get them right on the test. So let me put up a few questions tonight. I started that Friday and I just didn't finish it. So that's chapter 23. I'll put a few properties on, light properties on there. Speed of light. Reflection, refraction, and maybe polarization. I'll just make them concepts.
Thank you.
Yeah, thank you for asking that. I'll put a little something up. Maybe I'll just make a little announcement out of it. All right, what other questions? So, anything else? All right, I'll try to get this up in the next hour or so.
Thank you, Dr. Terrell.
Yep. Are we done? If anybody wants to hang around and ask me a question or two, I'll stay around for another couple of minutes.